Hello everybody, my name is Kimal Alajam and today we will study vectors. Physics is a quantitative science. Quantitative in the sense that it deals with things that can be measured. Now, anything that can be measured is what we call a physical quantity. So a physical quantity represents anything that can be measured. A common example of a physical quantity is mass. You can actually measure the mass of a cup or your mass, or you could measure volume, the volume of water in a cup, length, speed. You can also measure the force one exerts on another, the velocity of a moving car. You can also measure the pressure, like the pressure that the gases exerts inside of your tire. You can easily measure that with the use of a pressure gauge. You have acceleration of a car. These are all examples of physical quantities. When we look deeply at these physical quantities, we can categorize them into two groups. You have vectors and scalars. Now, a scalar simply is a quantity that has only a magnitude or a size. It basically has only a size. It really doesn't have a direction associated to it. For example, mass. The mass of an object has just a size. You can be light, you can be heavy, you can be 1 kilogram, you can be 2 kilograms. If I say that the mass of this pen is about, let's say, 10 grams, it's just 10 grams. It has no direction associated to it. So it's an example of a scalar quantity. Another example is area. You have volume. You have speed. Speed really just represents how fast you are moving, how fast an object is moving. How fast an object is moving is the definition of what speed is. So it has just a size, it really has no direction associated to it. On the other hand, vectors are quantities that have a size or magnitude plus a direction. Keep in mind that a vector is a physical quantity that has both a size and a direction associated to it. For example, displacement. If John moves 4 kilometers to the right, this represents the displacement of John to the right. Now you realize that it has a size 4 kilometers and it has a sense of direction to the right. So this is an example of a vector quantity. Another example of a vector quantity is velocity. Velocity simply represents how fast an object is moving in a given direction. How fast an object is moving in a given direction. represents how fast an object is moving in a given direction. So it is an example of a vector quantities. Now, there is a fundamental difference between vectors and scalars. Scalar quantities behave just like numbers. You can add them, they can never be negative. As a matter of fact, if you have, let's say, a bowl, and let's say you place an object on that bowl which is 1 kilograms, and then you add another object which is 3 kilograms, then you add another object which is 2 kilograms, then you could simply say that the total mass is just going to be equal to 2 kilograms plus 3 kilograms plus 1 kilograms, which will be 6 kilograms. Now, you realize that the addition of masses, really, we just add them like numbers. We don't care about the direction because really, it doesn't have a direction associated to it. But on the other hand, let's say you have John. If John moves a certain distance, let's say he moves a certain distance, 3 kilometers to the right, and then or 4 kilometers upwards. So the question would be, what is his displacement? Obviously, when you look at his movement, this is John's displacement. But the total distance traveled by John, the total distance is equal to 3 kilometers plus 4 kilometers, which is equal to 7 kilometers. The reason we have just added is because distance is a scalar quantity, and therefore we really do not care about the direction it takes. On the other hand, his displacement, we have to take into consideration the direction of motion. Remember that we have to take into consideration the direction of motion. So the displacement of John is actually would be this distance. Let's just call that distance x, and we are going to use the Pythagorean theorem to calculate x. X squared will be equal to 4 squared plus 3 squared. This is 25. That means that x is equal to 5 kilometers. What do you notice? You notice that in this particular instance, John's displacement is 5 kilometers, but his total distance traveled is 7 kilometers. So there is a huge difference between a scalar and a vector quantity. Now here's a word of caution. When you are dealing with scalar quantities, it's easy. You add them just like you add numbers. But when you're dealing with vector quantities, you have to be careful, because you need to take into consideration both the direction as well as the magnitude of that given quantity. Remember, you have to take into consideration both its magnitude and its direction. And that really makes physics a little challenging. The reason why the math in physics is a little bit different from the math in math is because most of the quantities that you are going to deal with in this particular course are going to be vector quantities. Therefore, the math is going to be a little tricky, because you are not just manipulating sizes, you are also describing and manipulating directions, and that complicates things sometimes. So you need to pay attention and make sure you understand the fundamental properties of vectors, because if you understand the fundamental properties of vectors, trust me, things will really be easy for you in this class. So let's get rolling. How do we represent a vector? Remember, a vector has a size and a direction. So in physics, vector quantities are represented geometrically with the use of a straight line arrow. So a vector is represented by a straight line arrow. It's important. The direction of the arrow is the direction of the vector. Now the length of the arrow is proportional to the size of the vector. Now I use the word proportional intentionally. And by that I mean that if the arrow is long, let's say we have here vector A and this is vector B. Obviously, the direction of vector A is equal to the direction of vector B, but the vector B has a greater size or greater magnitude compared to vector A. And also that means that the sizes here may not be actually true, but they may just represent an approximate estimation of the size of the vectors. But if these arrows are drawn to scale, then the size of the arrow will represent the size of the vector. Remember, geometrically, vectors are represented with arrows, with straight line arrows. The direction of the arrow represents the direction of the vector, and the size of the arrow is proportional to the size of the vectors. It will only be equal only if the arrow is drawn to scale. And that is rarely the case. Now, whenever you are writing a vector, in textbooks, vectors are bold. If you see a letter in a physics textbook that is bold, that represents a vector. But when you're writing a vector in this course, you will see me, I will write a vector and I will add a small arrow on top of the vector. The arrow on top of this letter signifies that the quantity A is a vector quantity. So now if I just write A, this represents the size and this represents the vector. Understand that? So we can either just do this. A represents vector A, B represents vector B. You notice that there is an arrow on top of each letter. But if I just write A, this is just the size of vector A. And if I just write B, this is just the size of vector B. So keep this in mind whenever you are manipulating vectors.